So here we have exercise 3 called ball class, where we're going to be talking about what are objects and what are classes. Okay, so what we're going to end up with is actually no different than the last file that we created, but it's going to be organized in a different way by taking advantage of object-oriented programming. Okay, so what's an object, right? An object is a specific instance of an abstract type, which we'll get to in a second. An abstract type is also a class. Okay, so it's a specific instance of something we understand more abstractly. So here, what do we have here? We have, this is my apple. I brought this for lunch today. This is a very specific apple. I'm going to eat it, right? So in comparison to that specific apple, a class is a persistent set of properties and methods across a collection of objects. So what would be the difference between the apple that I brought for lunch and generically an understanding of what an apple is, right? So apple, as just the most general understanding of it, is a representation of what a class would be. My apple is an object within that class, right? And a class has persistent values and methods assigned to it. So what can an apple do? Or how can we understand the specifics of an apple? Well, it has properties, right? It has color, it has the center of the apple, it has an overall size, and it has a weight, right? How heavy is it, right? Is it dense or not dense? And all apples also have a set of actions that they can do, or methods, right? Any apple can grow, right, from a bud to an apple. It can fall off the tree, right, because it has weight, it can fall. And because it's an organic thing, it can decay over time. Okay, so a copy of a class object inherits all the properties and methods of that class, and that's called instantiation, right? So whenever we have a class, we'll call it the apple class, right? Whenever we make a specific version of that apple class, these are all of our apple objects. This is called instantiation. So all the properties generically, size, color, weight, etc., and all of the actions that it can do, fall, grow, decay, all of those are transmitted to the apple objects by way of instantiation, right? So they inherit all of those properties and methods. Okay, so if we understand objects and classes, right, where does object-oriented programming come in? Right? Well, object-oriented programming uses objects and classes as building blocks, right? And this contrasts to doing so with variables or functions, right? In the last exercise we did, where we made our bounce and our drag function, we used all of the kind of elements of our code within the context of variables and functions. So those were the building blocks. If we needed another property for our circle, we had to write another variable. If we needed it to do something else, we would have to write another function, right? Classes in object-oriented programming, objects and classes are what you use as your building blocks, as opposed to variables and functions, right? And it's a particular way to practice that notion of modularity we were talking about when programming. So really, it's an approach to programming that allows us to take advantage of some key implications, right? If we're using object-oriented programming concepts, it's a way for us to intuitively think about programming as opposed to being more technical and having to kind of list out step by step what everything does. We can think, okay, well, I have something, let's call it an apple. I want it to do a set of actions and have a set of properties attached to it. That's objects, right? That's using objects. And then in that way, all of the things that go along with that are put into our object, and we don't have to think about them each time we're writing a new line of code. It's also a way to encapsulate complexity by way of abstraction. So to be able to manage if we have apples, oranges, peaches, and pears, and they all do something different, right? It's object-oriented programming allows us to encapsulate into certain blocks of code each one of those types, apples, oranges, peaches, pears, and then by abstracting them into types, it allows us to have a kind of clear way of going about working with those objects in our sketch. And of course, as we're talking before, it's a powerful way to utilize the notion of modularity, right? So that it's a way for us to develop our programs much more fluidly and quickly as we're trying to gain some more complex behavior or interesting visual behavior. Okay, so here's our class, right? And again, it has properties and actions, right? If we think about them beyond the kind of analogy to an apple, right? If we're talking about the specifics of classes inside of processing, there's a few key things we need to make sure that we specify each time we make a class so that we can use the objects that are instantiated from that class. First is the class name, right? What is it? Is it an apple, right? Or is it a ball or anything else, right? The next thing we need to specify are what are all the properties that go along with that particular class, right? Same as the apple, these are our weight, size, etc., color. We also need to have a specific method. All of the functions that are inside of our classes are called methods, and we'll have two types of methods. One is a way to construct or create a class instance, thereby creating an object. And all the other methods are ways to add functionality to our objects, right? What does it do? Does it fall or bounce or whatever? Okay, so how does that compare to the anatomy of a processing sketch? Well, we talked about the extents of the processing sketch, where all the global variables are, how the setup and draw are functions that encapsulate a certain block of code, right? Well, there's a similar kind of comparison if we're thinking about classes, right? The processing sketch has a name, whatever we've saved it as. So too does the class, right? The class here, it has a name. We have to specify what its properties are. Then, and the properties are accessible anywhere in the class. Then we have to have a constructor function and any other functions that we might want to have that define all of the methods for this class, right? Notice how there's an extra layer that we have to think about when we're working with our class. It's not just a global setup or a global draw, but all of the methods are enclosed in this layer of the class, and then the two specific method types that we'll be using are internal to that, the constructor and other. All right, and because we're working in time, we're going to use one of our other functions or methods is going to be called update, and everything else will just be related to update. So update will happen each frame as a way to have the behavior of our class objects be consistent through time. Okay, so whenever we're creating a class and we actually want to use it, what happens when in the context of our processing sketch when we're trying to instantiate a class object? Well, in our variables, we have to declare that we're going to make a class object. We'll call it my class. Then, whenever we're in the setup, we have to make sure that we call to the class constructor, right? That way, the object has been instantiated and can be used within the context of our processing sketch. Then, inside of our global draw, this is going to ping out to the update method, which will call to any other methods that we have within our class collection, right? The collection of methods for our class. Okay, so let's implement our bouncing circle by using classes.